20th century popular science fiction was marked by imaginative visions of how humans would colonize space. Despite the relentless pace of technological advancement, some of these imagined cosmic structures have yet to materialize. We don't see dozens of space settlements and stations orbiting the Earth, and perhaps that's for the best. Nevertheless, it's worth appreciating the scale of imagination not only among science fiction writers, but also within research centers. Hello, dear friends. In today's video, we would like to share with you concepts and collaborative developments from the Ames Research Center and Stanford University that were envisioned to exist by now. But before we begin, we'd like to ask you to subscribe to our channel and hit the notification bell so you don't miss out on our new interesting videos about the mysteries of the universe and our planet. When you read or watch old science fiction movies set in a time close to our own but imagined in the past, you often feel a sense of the future that never arrived. While progress has reached incredible heights in some areas beyond our earlier dreams, we still don't have titanic space stations orbiting Earth to the tune of classical music. Teenagers aren't cruising on levitating boards. The skies aren't filled with flying cars. Advertising dirigibles aren't urging us to move to outer worlds, and battleships still aren't blazing towards the Orion Belt, although maybe that's for the best. However, just because these remain fantasies existing solely in our imagination doesn't mean that no one has ever explored the prospects of this possible future. For instance, in the 1970s, the Ames Research Center collaborated with Stanford University on a series of studies regarding the creation of permanent space settlements and optimal designs for such structures. 50 years have passed since then. Real colonies in space have yet to be established, and it's uncertain if they ever will be. After all, you can dream all you want, but economic realities still apply. Nevertheless, those studies left behind a series of concept artworks, and sometimes when you look at them, you can feel that same sense of the future that never arrived. The Stanford Tor was a proposed space settlement, a large torus-shaped space station capable of accommodating anywhere from 10 to 140,000 inhabitants. NASA proposed the Stanford Tor during the summer of 1975, conceived by students from Stanford University to envision future space colony projects. A version of the Stanford Tor, albeit in a more detailed form, representing a concept of a ring-shaped rotating space station, was proposed much earlier by Wernher von Braun. However, that was purely a military development. So, the station consists of a torus approximately 1.8 kilometers in diameter to house 10,000 people, as described in the 1975 paper, rotating about its axis at a rate of 1 revolution per minute. This rotation creates artificial gravity at 1 g through centrifugal force. Sunlight is brought into the station through mirror systems. The ring connects to a hub via special spokes corridors. People and cargo can move within these spokes to the main axis and back. The hub, which is the rotation axis of the station, is ideally suited as a docking node for receiving spacecraft, as the artificial gravity there is negligible. The interior space of the torus is habitable, large enough to create an artificial ecosystem, a natural environment resembling a long, narrow valley with both ends curving upward, forming a donut. According to the project, the population lives here in conditions similar to a densely populated suburb, with sections for agriculture and residential areas inside the ring. The Bernal Sphere is a type of orbital station and space settlement proposed by John Bernal as early as 1929. It's a so-called space habitat designed for permanent human habitation. Bernal's original concept featured a sphere approximately 16 kilometers in diameter, capable of accommodating up to 30,000 people and filled with air. In a series of design studies conducted by Stanford University in 1975 and 1976 to explore future space colony projects, Gerard O'Neill proposed a modified Bernal Sphere only 500 meters in diameter, rotating at a speed of 1.9 revolutions per minute, producing similar Earth-like artificial gravity around the sphere's equator. O'Neill named his sphere Island 1. As a result, the internal landscape of the sphere would resemble a large valley running along the equator. Sunlight would enter through an external mirror network and be directed onto the sphere's interior surface through a large window at the pole. The spherical shape was deemed optimal for containing internal pressure and reflecting solar radiation. Moreover, due to its smaller size, the sphere was considered economically feasible. Therefore, O'Neill conceived the next generation of these space stations as an enhanced version of Island 1. Island 2 was envisioned to be approximately 1,800 meters in diameter, with a habitable equatorial circumference of 6.5 kilometers. At these dimensions, this environment could comfortably house around 140,000 people. In a rotating torus, and even more so in a sphere, there are limited areas where stable 1g gravity can be maintained. While a sphere has the most optimal surface area to volume ratio, if only the internal surface of the sphere is utilized, much of the area and construction materials used to build it would go unused. The torus fares slightly better in this regard, but still not ideally. An alternative to toroidal and spherical colonies could be cylindrical ones. In the book The High Frontier, Gerard O'Neill proposed making a space settlement cylindrical. In the book, he described space colonization in the 21st century using lunar materials. The O'Neill cylinder, also known as Island 3, consists of two very large cylinders rotating in opposite directions, each 8 kilometers in diameter and 32 kilometers in length. Both cylinders are connected at their ends by spokes through a system of magnetic bearings. By rotating, they create artificial gravity on their inner surfaces due to centrifugal force. Each cylinder is divided into 6 equal-length strip sections along its length. Additionally, external agricultural rings with a radius of 16 kilometers rotate at different speeds to support various types of agriculture. An industrial block is located in the middle where minimal or zero gravity facilitates certain operations for producing a range of materials. Thanks to its enormous internal volume, it was anticipated that the cylinder would develop its own weather system. To eliminate the colossal costs of transporting materials from Earth for assembly, these stations would need to be constructed using materials transported from space, for example, from the Moon using electromagnetic catapult. Of course, with current technologies, all these projects seem utopian. To be more specific, let's consider an example. The estimated weight of the Bernal Sphere is 4 million tons. Now let's take one of the most outstanding engineering structures of all time. The International Space Station, which has been orbiting for over 15 years, the ISS is home to 6 astronauts, weighs just over 400 tons, and the current cost of its construction is estimated at $150 billion. If we were to try to imagine how much time and resources would be needed to create the Bernal Sphere with current technologies, it's doubtful that a standard calculator would have enough zeros for that. Nevertheless, perhaps some of these developments will find their application, not now, not in 20 years, but over time, if and when we reach such a level of development and necessity. And who knows, maybe in some distant future such structures will indeed be orbiting in space to the tune of classical music. Thank you very much for watching. If you enjoyed this video, don't forget to like it and subscribe to the channel to not miss our new videos about the mysteries of space. Write in the comments what you would like to learn about in our next video. Thank you and see you next time.